So, tell me about Project Bile. Why the name?
Oh, I wanted it to have a short snappy name that didn't sound too official. When I started working on it, my girlfriend's mother had just had an operation on her bile duct.
So what does bile do? For example, I just lost my car keys. Will bile help find them?
No.
Oh, also I just forgot my Facebook password. Can bile retrieve it for me?
Sorry, no.
I have a team of badly managed programmers who work in a windowless basement, and I want them to write a tedium generation system that I can inflict on the world. Can I use bile for that?
I don't mean to be negative, but no.
Well, if it isn't going to help ordinary users like me, I don't see what the point of it is.
The truth is that you personally may not receive a tangible benefit from bile anytime soon.
Oh.
And I'm sure the tasks you mentioned are very important to some people anyway, but trying to apply bile to them would be like making a hearty meal out of a screwdriver.
But what do you say to a starving man when he comes to you and all you have to offer him is a screwdriver?
I don't know. It's a situation I seem to be in a lot. But anyway, Bile is a math software research project.
So it crunches numbers.
Actually, no. Bile does not use numbers at all.
How can you do math without numbers?
Better than that. Bile does math without sets.
So goodbye Venn diagrams. But if you are not dealing with collections of objects, then how does this work?
Obviously, most of the math we know is based on sets. But then I read a book by a man named Colin McLarty, and it made me realize that things don't have to be that way.
I don't understand. We learned about sets in grade school. They are fundamental.
Yes, but you also learned that Santa Claus exists, that crime cannot be profitable, and that the world is flat, because it's easier to draw maps that way. The truth is that sets are in a non-legacy platform like Microsoft Windows 2.0.
What would you use instead?
Topos theory, which is an abstraction of category theory, which is an abstraction of ordinary vanilla common or garden abstract algebra.
Is this like James Hines Irish whiskey being distilled 3 times?
Yes. Most mathematicians think it is a waste of time and consists of mechanically transcribing chicken scratches, like the monks of the Dark Ages, in a vacuous calculus of symbols, whose meaning has been systematically drained away. But I think it lets you concentrate on what is really important.
And what is that?
Well, for example, in the theory of permutations, we learn that there is a special property of the number 6.
What is that?
There are more permutations of 6 than there are permutations of 6. This is not true of any other number.
What is the significance of that?
To me it says that we are studying the wrong thing. It tells me that we are doing Dickensian mathematics, where the oddities we see reflect the limitations of the environment we are working in. The solution is to generalize and work on a more powerful platform where we can see more clearly what is going on.
So, what problem are you trying to solve?
In this math without collections, there is no concept of finiteness. This means we can't really work with anything that corresponds to numbers, and we can't impose finiteness restrictions on algebraic structures. So most branches of math cannot be moved over to the new theory. Hence the lack of interest from mainstream mathematicians.
How can you fix this?
People have tried, but the problem seems quite difficult. The last serious attempt was in 1975. I believe it is possible to continue that theory and make it work, and then we shall be able to do math without collections, and whole new areas of math will be opened up.
So what does the software do?
It lets you do calculations in Topos theory. I'm exploring the theory of parity, evenness and oddness of permutations, which is the first step to a proper definition of finiteness.
Please explain.
Suppose we randomly shuffle the element of a finite set with 3 elements. So if I have a cardboard triangle on a flat surface, and I pick it up and move it around and replace it, maybe in another position, I have permuted the 3 corners. But then I have either flipped the triangle over, or not. So the permutation was either even or odd. This happens for any finite set that is permuted, and I believe the theory of evenness and oddness can be generalized.
How will that help?
Because parity of permutations is a fundamental property that finite sets have. So if we understand parity, we understand finiteness.
Well, I'm completely lost, but anyway, good luck.
Thank you.